Let's understand SQL keys today. What are SQL keys? So we know we have three types of keys in SQL: primary key, unique key, and foreign key. So in today's session, we'll explore these keys in detail. So for that purpose, I have collated few of the questions which deals with the basic principles and fundamental of keys. So while discussing around these questions, we'll ask many questions of why and where and what, and then with the help of these the answer of these questions, it will be very clear and the fundamentally like what the keys are and how they are being used, and if something is not allowed or not permitted, why. Okay, so before starting with the session, I assume that you might have the basic understanding of primary key, unique key, and foreign key in SQL Server. If you do not have, let's begin with the first question: why only one primary key is allowed in a table? When I say is allowed, it means it's a table because the keys are related to tables in SQL. Okay, so we all know what is the primary key. If you don't know primary key, what primary key does? The primary key on a table ensures the uniqueness of every row. Okay, that's very important. The uniqueness of every row or data row in a table, not the column. Okay, although we define a primary key on a column, but it ensures the uniqueness of whole row. So sometimes if it is not possible to maintain the uniqueness just using one column, we use compounded column or multiple column to define our primary key, and then we call it compound primary key in some places. Okay, we'll explain furthermore about the primary key, but let's if you don't know how to create primary key, let's just begin with a very simple example. So here, let's say I am creating this table test2 in SQL Server. This is SSMS. I am creating this table with just two columns in it. One is ID and other is name, and you can see that I have said that no, not null. We'll discuss further more about the null, not null property of primary key as well, and then simply defining this column as an primary key. When you create this table, it's created in the database. If you refresh your tables, you will see this database. When you refresh the table, you will see test2 table, which is what I created here. You see the column, and you can see the column structure. That first column is named as a key. Okay, so this key defined as a primary key. Okay, and you can also see under the keys there is a constraint created on a primary key. This is how we create a primary key. Okay, and what primary key does? Primary key ensures the uniqueness of a row, entire row, not a column. So let's insert these two rows in this table, and as you can see that we define the primary key on ID column. Here what I have inserted is two different rows in this table with unique ID. So that's why it is allowed. Okay, and as we are saying that the ID column, we have defined the primary key on the ID column, so it means ID column cannot be duplicate. That's the primary definition of a primary key in the table. So here on, if I try to insert one more row with the same ID as I inserted one earlier, let's try this. It will give us like violation of primary key constraint. Okay, this is the fundamental of primary key. So primary key, if we define a primary key in a table on a particular column or the group of column, that defines that the uniqueness of those rows. Okay, and this is what the primary key does. But here the first question is why only one primary key is allowed. So if you try to create one more primary key on a same table, okay, so let's we have a table. Let's try to create a table here, and this to solve this question. Then we go in fundamental as well. So let's create this table 3, and you can see I am trying to define the primary key on both the columns. Okay, let's try. Not allowed. We know it that it's not allowed to have two keys. Let's create this table 3 created, and now try to alter it test3 and have a primary key on the name column like this way. still not allowed, right? It says that the table is already having primary key. So the question is, we know that, okay, only one primary key is allowed in the table, but to here question is why. So once you understand this why, it will be clear. As I said, what primary key does, primary key ensures the uniqueness of a whole data row, not a particular column. Okay, so and what to ensure this uniqueness, what it does, like what the primary key does, it creates a, by default it creates a clustered index on a table based on the column you define inside a primary key. So when we created a table, you can see whenever we create table test2 or test3, just check here test2 or test3 tables. As soon as you create a key here, it creates an index as well here. And if you see the definition of this index, right click and create. This index by default is a clustered index. Okay, so you can see this is a clustered key index. Okay, so what it does, it creates the clustered index on a table by default when you create a primary key. Now, what clustered index does actually? So there is the answer for this question. What clustered index does? So you know we have two type of indexes in our tables. Basically, two type of indexes when we say row store or column store. One we say clustered index, other we say non-clustered index. Okay, so what clustered index are? Clustered index are basically rearranging your table rows in a particular order. What does it mean? So let's say you have a table here. You can see this table structure here. Okay, this table is about like, let's say, customer address. So this first column says the ID. So this, you can say this ID is house number of the customer. This is the block, and this is the sector, and this is the district, and this is the state, and then so on. So this is a table structure. Now, if you define a primary key on let's say ID column here, so what it does in SQL, by default it creates a clustered index on that column as well. Okay, and what clustered index does actually, cluster index will physically try to arrange these rows in ascending or descending order based on how you created the index. When I'm saying ascending or descending, by default it is ascending order, or when you create manually you can give the descending order as well. As here we have not defined the order, we just created it as a primary key, so the default order will be the ascending order for the tables. So it means so let's say you already have a table with the data, but as soon as you apply an index or the primary key on a particular column, and if that index is a clustered index, then this entire table rows will be rearranged in ascending or descending order based on that column. So as soon as you apply clustered index here, you can see here these rows are not in order either, like they are not sorted ascending or descending, but once we apply the index, they get sorted here like this. Okay, so now you can see they are sorted in ascending order. So this is not just the column is sorted in the ascending or descending here. Here it is like whole row is sorted. So you can see against ID1 the block is C and then the 55, and here you can see it is 1 and C. So it means the whole row get in the order, and this order is a physical order. Physical order now means the data itself is saved in this order. So when you insert a new row and with the ID 7, that row will come here. Okay, or let's say you insert a row 10 first here, so that row will come here, and then say whatever you will do here doesn't matter. But once you enter one more row, let's say 7, like this is, so what will happen, SQL will rearrange these rows as soon as you will insert SQL will rearrange these rows, and what will happen, yeah, like this. As soon as you will insert the row, they will get sorted physically. So that's how the clustered index works. Now we are coming back to our question. Our question is why only one primary key is allowed. So what happens once this clustered index is like created, and they are created based on like the physical order. Now there is no other way to have the same, or I mean you can apply one more index, clustered index on the same table in another column, and then have this um, order maintained. So like what I'm saying, so let's say you already defined a primary key on this column. Now you try to define a primary key on this column. So what SQL will does, SQL will try to arrange the table based on this column. Okay, so as soon as it will try to arrange the column, arrange the rows based on this column, this arrangement will be destroyed. You can see, right? Either you can apply using this row, this column, and the entire row will be swapped or rearranged, or either this column or any other column. Okay, so it means once we apply when we try to apply to primary key, the whole concept of arranging the table will be destroyed. That is the first reason why it is not allowed. Okay, so you can see practically it is not allowed to have the table rows in a sorted order based on the two column. It is not allowed. It is possible that you can have this one as a 1 2 3 4, and whenever this column is matching, right? So let's say if we have here we created this based on the two that will come later, the two columns, then we can arrange like, okay, within one there is A B C, so we can arrange one and then A B C. That is possible, but not like you want to order based on one as well, and you want to order based on A as well. It is not possible physically. Okay, and the clustered index are the physical index. Physical index means they are stored within the row itself. They are not stored outside the row. So physically they order themselves. Okay, that's the first reason. Then comes the secondary. That's the main reason, and the second reason, I mean, here is I have some answers here. So allowing multiple primary key would create ambiguity in determining which key should uniquely identify a row. So this is what I was explaining here. Either when you apply 1 2 3 4 5, this is uniquely identifying this whole row, and when you say no, I am also trying to uniquely identifying with this row individually with using this column, it is not allowed. Either this will or the both will combined. If you want both, you can keep it one key itself. That is possible, but not the separately. Okay, when you define a primary key on a table, SQL Server and other database system automatically creates a unique clustered index or unique non-clustered index if a clustered index is already exist. Okay, that also we will try. Okay, since a table can have only one clustered index, allowing multiple primary key would conflict with their rules. So, and now you know why only one clustered index is allowed, right? Because clustered index physically try to sort the data based on the column you defined. So that's why. Now here also we got one more thing, that by default, as we created a table with primary key, it created a clustered index, right? But here it is like, by definition we know that it tried to create a unique clustered index, but if the clustered index is already present on the table and then you later try to define a primary key, then you can also create a non-clustered index. Okay, so we'll take that example somewhere, or maybe in between we'll cover that. Okay, so that's the first question, why only one primary key is allowed? Because primary key is basically in background, it depends on the ordering, or like on a clustered index which orders the table rows based on the column, and then there is just one way to physically reorder your table all the table rows. So there is just one way, either one column or another column. So that's why just one primary key is allowed to have that uniqueness. But that one thing is very important, that primary key ensures the uniqueness of whole row. Okay, that will come later. That I'm emphasizing on this term, that uniqueness of whole row, not on particular column. Okay, so in a table, when one column is unique, then it means the whole row is unique. Okay, or let's say when the combination of two column is unique, then the whole row is unique. What it means, you see here, this is 1 2 3 4 5, which is unique. Okay, but let's say in case you are seeing 1010 because this is house number. It is possible that the DD block is having row house number 10, and then there is a CC block as well having the same house number 10. So now this 10 is not unique, but in that case this column itself cannot be a primary key, right? But still, if you want to enforce the primary key, we will combine these two columns as a primary key. So the compounding of these two columns then is the distinct or unique. You can see the 10 and DD and 10 and CC, then this is still the unique. Let's say if there are like different the same block and same house number in different sectors, like sector 55 and 45, right? This is possible, right? Then what will happen in this case, you see this house number, this DD is the same sector, but then in this case the sector is different, the block is same, the house number is same, but sector is different. So in that case, if we compound these three columns as a primary key, still we can maintain the uniqueness, right? So that's why the concept of more than one column came. So that's we answered this first question, but while we'll covering all these 9, that the first will be very clear to you. Okay, the second question, why null is not allowed in primary key? Okay, so first thing is not null allowed? If you don't know that okay null is allowed or not, so let's say when you try to here have let's say 3 and AC insert worked, we know that we defined the primary key on ID column, this one, right? Now try to have one null. So whatever you give the second string doesn't matter, try to have null, and it says inserting null values is not allowed on that particular column because that column is a primary key column, right? Now question comes, okay, why it is not allowed, right? We know that it is not allowed in primary key. That's why when we define our table, we set as a not null. Even if you give null, if you not give it like null or not null, by default it will be created as a not null. That's clear. Now comes that, okay, why the nulls are not allowed? You can see why nulls are not allowed practically here. The same way, let's say these two, up to here we have this column as a unique column. We can uniquely distinct all the rows based on the one column only because we defined primary key on this column, let's say. As soon as you will try to have null here, right, and whatever value you give here, it doesn't matter actually, because in SQL, what is null? Null represents absence of value, okay, or it is an state of column, not a value itself. So as it is not a value, right, as it is not a value, you are not sure that whatever data comes in these columns for this particular row, because you are not sure about this value, how you will arrange these columns, right? You can see here when I say A to Z, right, here A to Z, these columns you don't know, like they will always come and at the bottom in Excel. You can see, right, whatever values you have here, it doesn't matter, these will always come in the bottom. So you cannot define the physical order of these rows here because of null, right? And as I said earlier, that the clustered index, it's like in the primary key, in the backend, it creates the clustered index, and clustered index physically reorders the data in ascending or descending order on based on that column where you define the primary key. So hence, as null is the absence of value, that the index will not be able to reorder these columns, these rows based on that column, because there is absence of a value. Okay, so that's the fundamental reason why nulls are not allowed. It is not that okay, it's not allowed, but there is a why. The reason how you will you know the order of what I'm saying, the order of, you don't know this row will come here or this row will come here based on these two. You got it? So this order you cannot define, and even the uniqueness as well. So as order you cannot define the ascending or descending, also you cannot define the uniqueness of this whole row based on these columns. So that's why nulls are not allowed. This is the answer for this. If someone asks, okay, null is not allowed on the primary key column, but why? Okay, so you will say that the primary key creates the clustered index, and clustered index stores the data physically in ascending or descending order based on that primary key column. And once we allow the null on that the primary key column, and as null is not a value, it's an absence of value, we'll not able to then uniquely identify the order of those rows where the null presents. So that's why null is not allowed. That's the precise answer for it. Then the third question. Okay. Third question is difference between primary key and unique key. Okay, so what is the difference between primary key and unique key? So first thing, primary key ensures the uniqueness of entire row, entire data row in a table. But the unique key ensures the uniqueness of that particular column where we define the unique key. What does it mean? It means when you created, let's say, table here somewhere, okay, this ID, and let's say you have an ID, name, and phone column in a table. So ID is the, let's say, employee ID. This ID will define that this whole row is a unique. Although the name is same, but because this column is different every time, so this whole row is unique, right? But this phone number defines that, okay, the phone number in this column is unique. So what does it mean? When there is a null, right? When there is a null in these rows, what will happen? SQL will not consider these null in the value counting itself. It means still SQL will just search that whatever the values are available in that column, they are unique, not the entire row. It is not worried about the entire row. It is only worried about that particular column. So when it will find the null values in that column, it ignores just those values and try to just have the counting of uniqueness only on the available value. So that's the first difference, that the primary key ensures the uniqueness of entire row, but unique key is concerned only with the defined column where we define the unique key. That's the first thing here. Okay. The primary key ensures the table has unique identifier for each row, and unique key ensures the uniqueness of values in the column or the combinations of column where we define the unique key. Okay. The primary key, that's why nulls are not allowed. We have seen, because we will not able to order the data. But unique key, one or more nulls are allowed. Why one or more nulls are allowed? Because unique key only concerned about the uniqueness of the data present in the column that time. Okay, so that's why it's allowed. Also, when you create a primary key, by default it's create a clustered index, but when you define a unique key on a particular column, the SQL by default defines a non-clustered index on that column. So we can see it practically. Take an example. Okay, so I'm creating a table here. I am creating a table here without any primary key. I will try to create a unique key here. So just you have to write a unique keyword and then try to create a table here. We created this table, test33. Let's refresh the table, check the 33. What happens? Right, we created. You can see we have a unique key. Okay, and then checks the index, and you can see we have an index as well. Once you see this index, expand it, it is a non-clustered index. Okay, so what are the non-clustered index? Clustered index sorts the data of the table physically. They reorder the whole table rows. But what non-clustered index does, this is not a session on the index. I will try to cover the indexes in detail in some other session, but in this session I will just explain that the non-clustered index are just the reference index, where it doesn't affect the real order of the table, whatever the order of table that remains intact, but it creates a separate reference data structure where it will have just order of the column based on where we define the non-clustered index. Okay, so it means it doesn't impact the data order directly in the table, but it will have a reference based on some that, okay, when you created, let's say, non-clustered index here on the phone number, so it will try to have another directory where it will define all the phone number in order, ascending or descending, and then it will have a pointer to the row where it has to find that phone number in the real table. Okay, so we have seen as soon as we created a unique index, unique index created a non-clustered index. Primary key creates the clustered index. So that's why in primary key nulls are not allowed, but unique key, because by default creates a non-clustered index, so here nulls are allowed. Then what is the next difference, right? Primary key, you can have just one primary key on a table, but unique key you can have more. Okay, so let's, what I'm saying, let's drop this table and try to have unique key. Let's say email is also unique, so let's have a unique key on this. Create again, refresh again, and just see the keys here. Now you have two unique key. Okay, and then just have the indexes. Now you have two non-clustered index, you can see, okay, on these two columns. So yeah, more than one unique key is allowed. The primary key, only one allowed. Primary key, uniqueness of row. Unique key, uniqueness of column data. Clear? Okay, proceed. So this is what the differences we have between the primary key and unique key. And what is the purpose of unique key? Unique key is the purpose of, like, when you have, let's say, employee table or customer table, right? We know that every customer is have a customer ID, let's say, in our table for analytic purpose or for the transaction purpose. That ID is unique for each customer. So because the ID is unique, it will maintain the uniqueness of entire row. But still you don't want that, okay, the email ID will repeat in the table. So for one email ID, there will be only one customer. So we can define a uniqueness on that email ID. Same way, only one phone number is allowed to be associated with one ID, employee ID or customer ID. So we can have maintain the phone number uniqueness, but it is not mandatory for the customer to provide phone number. So it means we have to allow the null in the phone number itself. So that's why unique key will allow the null there, even for the same, let's say, email. Customer don't want to provide the email, then email is also null allowed. So that's the whole purpose of a unique key, and you can have as many unique key as you want. Okay, so then the fourth question, is it mandatory to have clustered index on a primary key column? That's a very interesting question. Okay, so when you, by default, I created this test table 2 here, right? And I shown you the test 2 table have a key, primary key, and when you check the index, this is a clustered index here, right? But the question is it mandatory to have clustered index? No, it is not mandatory. Okay, you can create a primary key without even having the clustered index, but not by default. In that case, you have to define it like that way. So I have an example here for the question number 4. Let's say I will create a table, test 4. I have an ID and name, same column. Not null is needed for the primary key, but I can define it as a non-clustered. Let's try to create this table here. You see here, I created table 4, refresh table 4 and check the keys. You can see we have a primary key. Check the index, we have indexes, but what is the index type? This is a non-clustered index. So it is not mandatory to always have a clustered index on a primary key column. Okay, if needed, you can have a clustered index as well, but it will still maintain the property of primary key, like insert into this table, select one A, insert, and try to insert the same one again, and you will get the same error. So still your primary key is working, but with a non-clustered index. But it is not recommended until needed. Primary key with a clustered index is fine. Most of the cases, 99% cases, but you should understand the fundamental that it is not mandatory to have clustered index. In that case, not null, non-clustered index also works with the primary key. Okay, then question 5, is it mandate? So 4, no, not mandatory. If the table is already having clustered index, that is also. So let's, is it possible to create a primary key on a table where there is already a clustered index? This is also interesting, right? Now, like, this is opening a new questions for us. So you always know that, okay, when you create a primary key, it by default create a clustered index, and in one table we can have only one clustered index. Interesting. So what we are understanding here, is it possible to create a primary key on a table where there is already clustered index? Okay, so it means we already created a clustered index. So let's example, right? Create a test table 5. I'm just defining not null both the column here, and just creating a table without any index. Created a table 5 without any index. You can see there is no index, there is no key, there is no indexes right now in this table. Then let me create a clustered index. That's how we create a clustered index. So create a clustered index on this table 5, test table 5, created here. Okay, so I created a clustered index here. Now you refresh the indexes, you will see there is a clustered index. Now I will try to alter this table test 5 and try to have a primary key on an ID column. That's how we can create it. Okay, so if it is allowed, it will create a primary key. Not allowed, it will not create. Okay, so I tried and it created. Refresh the table, check your keys, you have primary key. Okay, now check the indexes. Now see what happens. When we created a primary key and there was already a clustered index on that table, it created a non-clustered index on that particular column, right? So use the table is being ordered based on the name column, and based on the ID column, this non-clustered index is pointing to these rows. Okay, that is a detailed cluster non-clustered index topic, how actually they works in the background. I will cover some other session, and you can just follow my videos, my channel for the further detailed session on the indexes as well, to understand with the questions. So these are some very basic interview questions. If someone want to explore your whole knowledge about the indexes, the fundamental knowledge, they will ask question like, okay, is it allowed? Not allowed? Why? Okay, so it is allowed if the clustered index is already there. Primary key will by default create a non-clustered index on that column and then point to the clustered index in the backend. So the answer of this question is yes, allowed. So, and then coming to question number 6, can you have more than one unique key in a table? Yes, we have. I already given that example that we can have more than one unique key, and then the reason for it is that it only ensures the uniqueness of that particular column, and unique key only creates a non-clustered index. And in a table, as a non-clustered index are not the physical index, they are the reference index, we can have multiple non-clustered index. So you can have only one clustered index, and you can have as many as non-clustered index with the different combinations of columns as well. So this is also answered question number 6, because it ensures the uniqueness of the column value. Now comes the question number 7. Nulls are allowed with the unique key? Yes, nulls are allowed with the unique key, and the reason, as I explained here, the reason for it is that when you define null on the phone number, what SQL does, SQL will try to ensure when you try to insert this one, this 99 again, right? It will say no, not allowed. Okay, but nulls are allowed. We can do it practically. Okay, so let's insert something here. So we created this table with having 2 unique index. So I am always inserting by select example. So select 1 AA, and then let's say phone number is 999, and then email ID is abc@a, and try to insert it. So when I say select, right, so this is the result of select, and I insert this in this table. Inserted, try to have next row 2 whatever the name, because it's not, and I just will have this as a null. You see here, this is null, but this 999 is not unique, so it should not be allowed, not allowed. So it says unique key constraint violation, right? But if you try to have, sorry, not this like null, but if you want to have nulls here as well, right, both column as null, try allowed. Okay, I did 3, one more column, one more row with a null column. In many SQLs, multiple nulls are allowed, but in unique key in SQL Server, only one null is allowed. So even if I will give some value here, and try, it will not allow because we already have null, so it allows only one null in SQL. Okay, so nulls are allowed in SQL Server, but just one for the unique key, but you can have multiple unique key in same table. Okay, so nulls are allowed, but only one. But this is not true for all the SQLs, because in Oracle there might be multiple nulls are allowed. So multiple rows will have the null value for the unique key, but in SQL Server just one null is allowed. The second null is considered as the duplicate value. Okay, coming to question number 8, primary key and unique key on the same column. Interesting. So if you try to create a table where you are defining primary key and unique key on the same column, 8, right? So let's have the primary key. So I'm creating a table 8, just practically. Okay, creating table 8 where primary key on ID column, and I'm defining the other column as a not null. Okay, so here it created this table, refresh, table 8, here key, I have a primary key, I have 2 columns, this is also not null column. Let's create a unique key on the same ID column. Okay, for table 8, try to create it. Interesting. Refresh it. Yes, interesting, right? So okay, it created just a non-clustered index, but not the key as a unique key. Okay, so when the question is, can you create a primary key and the unique key on the same column in same table? Okay, so created a table where I have a primary key on ID column, not null, and name column is also not null. Now try to define, and so here you just check the structure of table 8 here, right? We have primary key here. In keys we have primary key, and indexes we have one clustered index. That's the default nature of SQL. When you create an primary key on a column, by default it's create a clustered index. Now we'll try to create a non unique index on ID column where we already have a primary. Okay, so when you try to create a unique ID, so which is basically it creates the unique index. Okay, when you try, what it does, in keys you will not see any change here. Okay, because there is already a primary key, so you will not see any change in the keys here. But when you check the indexes, it will have one more index. So now you have a clustered index and you have a non-clustered index as well. It's not required, but it is possible to have clustered index and non-clustered index on the same column in SQL. It is not that okay, it's prohibited. You can create it, but mostly it is not needed or not even recommended. But as an like there is no limitation, but you cannot see a unique key here. Okay, because there is already primary key which serves the same purpose, uniqueness of entire row when you are defining on that column. But you want for that only column purpose only, so it's not needed because the primary key is fulfilling the purpose of unique key here. So it is allowed that it will just create the non-clustered index, not the actual primary key, actual unique key. Okay, then comes the last question, primary key and foreign key on the same column. This is also very interesting. You know what is the purpose of foreign key? Foreign keys are just to have a relation, just to define the relationship between the two tables based on one or multiple columns. What does it mean? A simple example, we always have like customer and order table. So in customer table, you have customer ID column and then other column like customer name, address, and other details. And in order table, you will always have that order ID, customer ID, and then order date and rest of the columns. So here, you know that the customer ID column of customer table is in relation with customer ID column of the order table. That's how these two tables are related. And then we use the join, inner join, left join to explore this data or even update or delete this data. That's the purpose of foreign key. Foreign key basically maintains the integrity of data. Integrity of data means that, okay, whenever you have a customer in customer table, then only you will have an order in the order table with that particular customer ID. That's the purpose of foreign key. I'm not going in detail because it's a fundamental concept. You can learn anywhere the foreign key. But the question here is that, is it possible to have primary key and foreign key on the same column? Is it possible? So let's say this is the referential one, not this one. Let's say I'm creating a table for you. Okay, so when I'm trying to drop it, it is not allowed. So let's drop that 8. Sorry, here the 888 referencing the 88. So let's first drop this table. I'm dropping here, dropping this table as well. So I am creating a table. You can see I have an ID here, which is primary key. So mostly these relationships are primary and foreign key. And I have another table where I have an ID as a primary key and the name, another column, and then I have a foreign key on the same column, ID itself, and which is referencing this table, this column. And this is the question: is it allowed to have the same column as a primary key as well as the foreign key? Let's try to create this table. Yes, it is allowed, right? So you can have a same primary key and foreign key on the same table. So now how it works? How it works practically? What is the example for it? Example for it that you always think of employee ID, name, and then in order table, order ID, customer ID, and then date, something like that, those columns. And you see that, okay, if this is a primary key of the employee table, sorry, this is customer, and this is the primary key of customer table, and this is the primary key of order table, but this is a foreign key where you have a relation between this table and this table based on these columns, right? So these two tables are in relation, and then you can have multiple rows here for same customer, and only the customer which are present in the first table that will be there in the second table, which maintains the integrity of data. Okay, but then there can be cases where you have, let's say, another table where you have, let's say, customer ID and credit card number. There is possibility, right? So if, let's say, we are allowing just one credit card number per account, so these are your customer, and then this table, you want to maintain this table separately because it's having the customer credit card data, so you want to maintain it separately, right, with the security purpose, or you want to encrypt or something like that. And this is your this is the customer's credit card number. Now you can see that this table is having customer ID as a primary key. It is because you want to have just one customer having one row here, and then these two tables are related based on this column also, right? So in that case, this ID, customer ID column will be the primary key for this table, and then we'll also have the foreign key for this table reference. So yes, it is allowed, and this is the practical scenario, and it is very much allowed. So now one more extra question: is it allowed to have primary key and foreign key within the same table? So here this is an example of two different tables, 88 and 888, right? And it is allowed, that we all know and we have read. But this is interesting question: is it have, like, the same table will have the primary key and foreign key? So let's discuss this. So I am creating this table test 8 where ID column is a primary key column, name is not null column but not a key column, But then we have manager ID, and we have seen these tables like in case of employee where employee ID and then the manager ID. And as the manager itself is also the employee itself, right? So manager ID, here I am defining a foreign key on the manager ID based on the same table 8 ID referencing. It means whatever comes in the manager ID will be the part of ID column itself, right? Let's create this table. It is allowed, and it is very much allowed. And if you want to check it how it works, right? So let's try to insert data in this table. Insert into test 8, select customer ID 1, name as AA, and let's keep the first as a null because first null is allowed, right? So I did null. Let's have customer 2 and employee 2, and I'm giving manager ID as a 1. It is allowed, right? Because I already inserted manager, right? I will give 3 here, I will give 2 here, whatever name doesn't matter, right? It is allowed here. But as soon as you will say, let's say 4 here and 5 here, and you see the manager where the ID is 5, and we know that we have inserted only 1, 2, 3 in this table. There is no employee with an ID as a 5, right? So this shouldn't work. And you see it is not working because there's no ID as an employee ID 5 exists in the table right now. So this is called like the same circular primary foreign key reference in the table. You should be very careful while creating these references. It's very rarely needed, but yes, it is allowed. So that this was an extra question. Okay, so here we covered all our questions. These are very fundamental keys related questions, theoretical, and I tried to explain practically as well. And once you try by yourself and once you have the grasp of all these questions, I'm sure like you need not to remember all these in the future ever. This is just a concept. Like once you understand the concept, you need not to remember. If you have any further question, you can comment on my video. You can ask. I will try to explain it. Thank you. If you found this video is useful for you, please like my video, subscribe my channel for more videos. Thank you.